Hello, in this video I'm going to do a few more examples with transformations of sine and cosine. Alright, so the general transformation is viewed here for either a cosine or a sine graph, and let's just recall what these parameters, capital A, B, C, and D, accomplish to the graph. Right, so the number in front that we're multiplying by, that's the vertical shift. This is going to, the vertical stretch. That's going to affect the amplitude. Alright, so the amplitude is going to be A, or if A is negative, it's its absolute value. Alright, so again, if A is negative, we know that it's going to reflect the graph over the x-axis also. We've got to be a little careful with what we have inside the trig function. Alright, the way they have it expressed in the book is bx minus c. What we want to really do is factor out that coefficient of x to view this as a two-stage transformation on the inside that has a horizontal effect. The period for this is going to be determined by the number b, alright, using our normal formula, our normal result that the period is 2 pi divided by whatever that number b is. So if b is larger than 1, the period will be shorter than 2 pi. If b is less than 1, it'll actually be greater than 2 pi. Alright, and then, so that's one of the inside effects. The other is what's resulting by either adding or subtracting. I have it written as subtraction here. This is going to be a shift either left or right depending on whether that ratio C over B is positive or negative, but it's going to be a shift left or right C divided by B units. Alright, again, if that comes out to x minus a number, that's going to be a shift right. If it's x plus a number, that's a shift to the left. The entire graph gets shifted. And then lastly, on the outside, that's the easiest. That's going to be shifting up or down d units. All right, and again, if we're adding a negative, adding a number there at the end, it's going to be up. If we're adding a negative number, which is subtracting, the graph is going to be shifted down. All right, so let's just do a couple more examples, and I have a couple from the homework that I want to work out. Okay, so I would like to redo number 5, just a different version of this. So it's saying, given the graph, there's several questions in the homework like this. Given the graph, come up with the formula, come up with the equation of the function f of x. All right, so we have to decide, are we going to have a transformation of sine or cosine, and then figure out the relative numbers in there. Okay, now for this graph that I'm given here, we're going to look at x equals 0. All right, now this graph, halfway down it, all right, so if we see the lowest points are down here at height negative 9, the highest points are at height y equals 1, halfway between that, that's 10 units, we're going to be at negative 4. So halfway above negative 9, below positive 1, we're at negative 4. And then just thinking about going to the right, we're going up, and down, and then back up again. And thinking about our 5 key points for these trig graphs, this looks more like a sine graph. So we're thinking this is going to be a transformation of sine, and we need to figure out what this transformation is here. Alright, now we'll start to fill in some of the details. The number C, it's not shifted left or right at all, so that's going to be 0. So that's fairly straightforward in this problem. C is 0. What about the amplitude? Okay, we're asked to give a couple other things in here in the problem. We want to know the amplitude, the period, which is going to be related to the number b, the midline, and then find the equation. Those are the 4 things we need to do. All right, so the amplitude, let's think about actually the midline first. This graph is cut in half according to its midline, and that midline is the line y equals negative 4. It's the horizontal line y equals negative 4. So that'll be part of our answer. But the amplitude is the distance from the midline to the high points, the peaks, or we can think about it from the midline down to the low points, the troughs of the graph, and that's clearly 5 in this case. So the amplitude is 5. All right, so that's going to say capital A is 5 in our formula. All right, C is 0. All right, we're going to worry about that. What is the period of this function? Well, we can see it does one cycle between x equals 0 and x equals 3. All right, so the period, which we denote by capital P, is equal to 3. All right, now for us to figure out what that number b is, in our formula we need to use the relationship that the period is equal to 2 pi, the normal period for sine or cosine, divided by that number b. This is a little backwards from some of the other problems where this time we're given the period as 3 and we need to go through and find b from this. Okay, a couple ways we can go about solving it. I'm going to multiply both sides by b to cancel these b's out. Rewriting this equation, we've got 3 times b, or b times 3. 3b equals 2 pi. Dividing both sides by 3 then, we would get our value for the parameter b as 2 pi over 3. Alright, so we've got 2 of the numbers we need. Now, what else has happened to this graph? Alright, we said it hasn't been shifted left or right. It has been shifted down clearly though. The midline for the normal trig function sine of x is y equals 0. We shifted that midline down 4. Alright, so this number d in our formula is going to be -4. Okay, so let's write it out and then we will input it. Alright, so we've got y equals, in this case, it's going to be a, which is 5. Alright, it's positive 5. Let's go back up here again. This does the normal pattern. If this was flipped upside down, we would have to have -5. And then we determine what b is. It's sine transformation. The number capital B is 2 pi over 3. X plus or minus nothing because we didn't shift it left or right. And then this went down 4, so we could put plus -4 or simply -4. Alright, and I'll flip over and input that into the homework quick. And then we'll do another example. Alright, so this problem, again, we were told to find the amplitude. We figured that out as 5. The period was 3. Again, that's not the number b, but that's the period over which we're completing one cycle. The midline, we have to type the equation in y equals -4 here. Now for the function, it says use f of x as the output. We have to actually put in f of x equals our formula, which was 5 sine of 2 pi over 3 x, and then -4 was what we had on the outside. Alright, so substituting those things in, that's number 5 in the homework. Alright, we're going to do another one here in a moment. Alright, and the one we want to get to next here is number 12. Oops, sorry, I lied. Number 13. Okay, so this one we want to sketch the graph of this function, so we need to know how to sketch this out. Alright, so I'm going to bring a screenshot over that over to OneNote and we'll work it out. Alright, so here we go. We want to sketch this graph. Alright, so it's a transformation. We know that the number in the front, that's actually going to do 2 things. It's going to make the amplitude 2. Alright, the number in front's -2, but that's going to mean stretching it by 2, and then the negative sign is going to be reflecting it over the x-axis. Alright, we got a little something on the inside. The coefficient of x is 1, so it's not affecting the period whatsoever. So the number b is equal 1, which means the period is 2 pi over 1, so it's the standard or usual period for cosine in this case. This number on the inside makes us go right by 4 pi over 3, and then the last number, that's going to make us go up 1. Okay, now I'm going to go over, I'm going to sketch it quick here and then by hand, then we'll input it because something kind of peculiar happens with this one, and depending on the numbers that you get generated for number 13 in the this problem in the homework, it might come up like that for you as well. Alright, so I'm going to not do the shift up here. Alright, I'm just going to mainly do the first 2 parts. So normally at x equals 0, we'll be starting at 1. Alright, we stretched it by 2. That would make us go up to height 2. Alright, but now we need to reflect that over the x-axis, so we actually want to draw this down at -2. Alright, and then we would be at 0 at pi over 2. And then we'd go up, in this case, to height 2 at pi. Right? So we'd have these 5 points. Alright, and our graph would look something like this. Okay, we would repeat that pattern going forward and going backwards. Alright, that's fine. Now, to finish it, we would have to then shift these points all up. So all of these points that we drew here would just get straight shifted up 1 unit, and then we would redraw that pattern there. Alright, and that's what we're going to do in the homework problem and just illustrate how that's going to be done. Okay, so let's go back over. Alright, now when we do these problems, the left tool at the bottom is the cosine, the right one is the sine. You have to put 2 points down. It's indicating the top, kind of in the bottom for that first one, bottom first and top, or you start at the middle and then go to the top of the first peak. All right, so we're going to use the cosine graph. So again, we're going to be at -2. So I want to start at -2, and then when x is pi, halfway through our cycle, we're going to be back up to height +2. So that took care of the -2 in the front. All right, now we will be shifting this up eventually, but I want to shift it right by 4 pi over 3. And that's where the problem comes in. Depending on the numbers you get generated, if you have one like mine here, you want to really drag this point 4 clicks to the right. Shifting it, and if you look at the scale that's built in the problem, it's going up in steps of size pi over 3. Pi over 3, 2 pi over 3. Another step would be 3 pi over 3, which simplifies to pi, 4 pi over 3, 5 pi over 3. So this grid is built that way in the problems. But I can't move this point right here that I plotted for because I'm running out of grid there. All right, so what do? Well, you can figure out how much you'd have to back it up this way to get the same graph, or clear that out or move these points around. What if we instead started graphing this point and then graph this as our second point? So we can just move that, and that's the same graph. All right, but now I can shift these points each right by 4 pi over 3. Sorry, hit the wrong button. All right, so let's do that now. So we're literally just going to pick each one of these up and just move them over. Again, count over 4 clicks. Just left click, hold, and drag it over. 4 boxes. Put that down. We're going to go over 4 boxes. There we go. All right, now we need to go everything up. So take each one of these up 1. And that's what our solution should be. Okay, submitting it, we're correct. So you just watch out for that. For some of these problems, you might run out of real estate, and therefore you might want to move left or right as needed for your problem. Okay, I'm going to go back and maybe do one more example, which is number 7, and that'll be it for this video. All right, hopping over to our notes. What's happened here? All right, how did we look at this? You got to make a choice whether you want to treat this as a sine or a cosine. You can do it either way, for at least for the problem that I have. I'm going to choose to do this as a sine just to illustrate it. So I'm going to think my first point is right here. Then labeling our 5 key points for our trig function, we can see it completes one cycle from -3 to +5. So that's going to tell us our period is equal 8 units of length. All right, again, we would substitute that in then to our format, 2 pi over b to try to find b. All right, so we put in 8 for p. All right, and then it's going to turn out that this is swapping sides with the b and the 8, so we're going to have 2 pi over 8. I'm skipping some of those details, which tells us b is pi over 4. Okay, fine. That's how the period gets affected. The amplitude we can see is 2, right, from the midline up to the height, the highest and lowest points. That's length 2. All right, again, we're doing a sine transformation, so we've got a sine of b, and then it's going to be x minus something there, plus or minus something, and then we're not shifting up or down at all, so that's going to be it there. Now, how much is this graph shifted? Well, the amplitude, all right, and the way I started this, the number a is going to be -2 because it would be an upside down sine function. It's shifted left 3 units. Okay, left 3 means we want to do +3 on the inside of the trig function there. So when we go to write this out, the function is going to be -2 times sine of our number for b was pi over 4, and then in parentheses I'm going to write x plus 3. All right, we're not shifting up or down at all. I'll go enter that and we'll check it. All right, submitting it. Forget what I got going on here. Okay, so just to wrap up, I had a pop up on my computer. All right, so that's it for that example in this video.